Hello, bom dia. My name is Bruce Lewenstein, and I teach science communication at Cornell University in the United States. I've been teaching there for 32, 33 years, something like that. Before I was an academic teaching at the university, I was a science journalist for several years. And even since I came to the university, I have spent time working with science museums and citizen science groups and community outreach groups and a variety of areas within the overall field of science communication. Why do I think science communication is important? It's important because it's a fundamental part of the scientific process. I know we often talk about science as though it's that thing that happens in the laboratory, and and only later does it sort of go out to the public, um, to journalists or to museums or textbooks or whatever. And maybe there's that point in the middle that's the scientific journal. But really, when we talk about science, we're talking about what happens in the lab, and that just isn't true. It turns out that what happens in the lab is really important, or in the field, or whatever kind of work you do, is really important. But if all you do is do that technical work, then it's not actually science. It's some kind of collected information. What makes something science is the fact that other people have had a chance to test it, to test your conclusions, to see if they can gather the data the same way, to talk about different ways of interpreting the data. And when more people have had a chance to look at the data, to test the interpretation, that gives it a collective weight that comes from the social consensus, the social process of communication and discussion, that gives the data and the conclusions weight. And it's that collective judgment that makes something science, or makes it reliable knowledge that we can use to build new knowledge and to add on to other things and so on. So communication, which is that process of interaction that involves reading the article, testing the article, having you present something in public, and so forth. That is a fundamental part of the scientific process. Without that communication, you're not producing reliable knowledge about the natural world. So, if communication is fundamental to science, one of the necessary implications is that you have to communicate about science if you want to be doing the whole scientific process. Now, there's different kinds of communication of science. And so it's pretty common when you're learning science, or if you're someone who's teaching science, that you say to people, well, you have to do lab reports, or you have to submit your field notes. But it tends to be treated as something extra. And so what I think is really important if you're teaching science is to teach that communication process as part of the process. That it's not just that, oh, you have to write it up, but here's why you write it up. You write it up so that other people can test it, so that we can come to a collective judgment about what counts as reliable. Think about it this way. You have a bunch of people, let's say students in a laboratory, and you're asking them, this is probably at a elementary school level, so I think, if I understand correctly, many of you are going to be teaching science to teenagers, but let's look at a slightly younger level. You've got a bunch of people, they're all boiling water, and you ask them to put a thermometer into the beaker and say, what temperature does water boil at? You've got, I don't know, 15, 20, 30 kids in the room, and most of them say, oh, let's see, I'm getting 99.5, and someone else says, I've got 99.7, and someone else says, I've got 100.1, and somebody says, I've got 100 exactly, and someone says, I've got 100.2, and one person says, I've got 87.6, and everybody sort of looks at that person a little funny, and then people start reporting, and I've got 99.x, and someone says, I've got 92, and someone else says, I've got 103. Someone says, I'm at 100.1, and I'm at 98.5. And you get all the 30 of these collected. and you look at them and they clearly cluster around 100 degrees centigrade. Okay, so the easy way of making a conclusion is to say, okay, so the answer is water boils at 100 degrees. But you also then need to explain away all those ones that weren't exactly at 100 degrees. So how do you do that? Well, the person at 87, they were just, that's a complete outlier, something was wrong there. What about all those ones, 92, 98, 102? Where did those come from? Well, you look at the one that maybe that was at 98 and you say, you know, we started by putting ice cubes in and then we started boiling. So maybe there was a little bit of ice left, and when you put the thermometer in, you were accidentally touching what was left of that ice cube. So that pulled it down a little bit. And maybe the fact that it wasn't all at exactly 100, well, you know, the textbook, when we look there, tells us that actually it's 100 degrees at sea level, and we are at a different elevation here, and so maybe we were getting a slightly different number. But that's a discussion process that happens among all of you as you are all reporting, communicating your results, and trying to figure out what is the right answer. So you use that example to show the importance of reporting your results and talking about them and collectively coming to a judgment about what the right answer is, even though almost nobody got actually exactly 100.0 degrees on their thermometer. That tells us how important the social process of communication is in science itself, and why you have to teach about that social process, even what you're doing is teaching science. Now, you also want to teach about science communication because, in fact, for any student who might be involved in science, there are aspects of that communication process that will just keep on happening. So they do have to learn how to write it up. And they really should understand how journals work and what a preprint is and how an archive works and why on the internet today you can get articles that seem to be scientific but maybe aren't exactly scientific, or maybe they really are scientific and you're getting the actual version. And so you need to have people understand what that is so that whether or not they go in science, they can understand how to filter the information that is out there that they'll get on the internet. There's a more public reason for talking about science communication as well, and that's the fact that science isn't just the technical reports, it's also the stuff that does appear in newspapers or websites or on television or in video games or that shows up in Hollywood movies or things like that. And a lot of scientists are involved in that kind of science communication. Some people who have just a first degree in science, some people who've gone all the way to a doctorate in science, they will do some of that public communication as part of their work, or maybe even they'll make it the fundamental part of their work. It'll be the core of what their work is that public communication. There are all kinds of skills that are associated with every one of those steps, from the journal to putting science out on television. Things about understanding what's important, about judging your audience. Who exactly are you writing for or communicating for? That's that's perhaps the fundamental aspect of communication, is thinking about who your audience is and how do you tune the work for them. So this is not the place for me to talk about all of the details of those skills, but I hope that I've succeeded in making an argument to you that you need to think about science communication as fundamental to learning science. And if you are the one teaching science, then you need to be teaching various aspects of science communication as part of what you're teaching. So I hope this is useful, and good luck in your teaching and in your own learning. Obrigado.